Hi and welcome to the session. In this session, we are going to discuss the topic laws of spectroscopy from the unit 5 spectroscopic techniques. In the last session, we have discussed about the introduction of spectroscopy. Definition of the spectroscopy was discussed, while what is the electromagnetic radiations, how the electromagnetic radiations interacts with the matter, that has been discussed in the last session. Now in this session we will discuss about different laws of spectroscopy. There are three well-known laws of spectroscopy that we are going to discuss here. First law is the Lambert's law, second law is the Beer's law, and third law is the combination of Lambert's law as well as Beer's law. As these are the laws of spectroscopy, the laws are based on interaction of the matter under analysis with the electromagnetic radiations. Now we will start with the first law, that is the Lambert's law. The Lambert's law is the law which deals with path length of the media. So here it states that when a beam of monochromatic light is allowed to pass through a transparent medium, then decrease in the intensity of the transmitted light is directly proportional to the path length of media. So that is the statement of Lambert's law. Again I will discuss the statement of Lambert's law. When a beam of a monochromatic light is allowed to pass through a transparent solution, then the rate of decrease in the intensity of light is directly proportional to the path length of media or thickness of media. Simply, it indicates that when the path length increases, the intensity of the transmitted light decreases. Okay. Now, this law can be mathematically expressed as minus di upon I0 will be directly proportional to dB, where di is the small change in the intensity of the light. I0 is the intensity of the incident light, while dB is the small change in the thickness of media. So this equation can be written as minus di upon dB will be equal to k into I0, where k is the constant of proportionality. So integrating the equation within the limits, when I equals to I0, then B will be equal to 0, and when I equals to IT, then B will be equals to B. So by solving this integration we will get the formula, that is ln of I0 upon IT will be equal to K into B. That can be also written as IT is equals to I0 e raised to minus KB. So in this equation, I0 is the intensity of incident light, IT is the intensity of transmitted light, B is the thickness of media, while K is the absorption coefficient for given wavelength and medium. So based on this derivation, the Lambert's law can be also defined as the intensity of transmitted light IT decreases exponentially as the thickness of absorbing medium increases for a medium of fixed concentration. So that is the Lambert's law. Now we will discuss about the Beer's law. Beer's law deals with the concentration of the media. So here Beer's law states that when a beam of a monochromatic light is allowed to pass through a transparent medium, then intensity of transmitted light decreases with increase in the concentration of the media. I will again repeat. When a beam of a monochromatic light is allowed to pass through a transparent transparent solution, the rate of decrease in the intensity of light is directly proportional to the increased concentration of the solution. So here, in simple words, we can say that as the concentration of the media increases, the intensity of the transmitted light decreases. So similarly, the statement of this Beer's law can be represented mathematically as minus di upon I0 is directly proportional to the dc, where di is the small change in the intensity, I0 is the intensity of the incident light, while dc is the small change in the concentration of given analyte solution. So this can be also written as minus di upon dc is equals to k dash into I0. Here k dash is the constant of proportionality. Again, integrating both the sides within the limits that when I equals to I0, then C will be 0, and when I equals to IT, then C will be equal to C. So we will get the solution, that is ln is equals to I0 upon IT, that is equal to K dash C. This can be also written as IT is equals to I0 into e raised to minus K dash C, where I0 is the intensity of incident light, IT is the intensity of the transmitted light, C is the concentration of the media, K dash is the absorption coefficient for given wavelength and medium. So based on the derivation, the Beer's law can be also stated as the intensity of the transmitted light, that is IT, decreases exponentially as the concentration of absorbing medium increases for the medium of fixed thickness. So this is the Beer's law. Now Beer's law as well as Lambert's law are combined together, and we will have third law of the spectroscopy, that is called as a Lambert's-Beer's law. It can be stated as when a beam of monochromatic light is allowed to pass through a transparent solution, then the intensity of light decreases with increase in the concentration of the media as well as thickness of the media. So again I will repeat, when a beam of monochromatic light is allowed to pass through a transparent solution, the intensity of transmitted light decreases with increase in the thickness as well as concentration of media, which can be also represented mathematically as minus di upon I0 is directly proportional to dB into dC, where I0 is the intensity of incident light, di is the small change in the intensity, dx is the small change in the thickness of media, and dc is the small change in the concentration of media. So this can be also written as minus di upon I0 is equals to K into dB into dC. So integrating both the sides by taking one constant, that is either concentration or thickness, and other variable, the final solution we have got is ln of I0 upon IT is equals to K into B into C. This can be also written as log of I0 upon IT is equals to 2.303 K into B into C. So log of I0 upon IT is equals to epsilon into B into C, which can be also written as A is equals to epsilon into B into C, where I0 equals to intensity of incident light, IT is the intensity of transmitted light, B is the thickness of media, C is the concentration of media, and epsilon is the absorptivity constant. So, in summary, we have learned about what is Lambert's law, what is Beer's law, combination of Lambert's law and Beer's law, that is Lambert's-Beer's law, absorption, transmission, molar absorptivity or molar extinction coefficient. Thank you.